problem is remove nth node from the end of the list. So given the head of a linked list, remove the nth node from the end and return its head. So let's understand this using an example. So if we are given this list 1, 2, 3, 4, 5, and if n is equal to 2, then we need to remove 1 and 2. Basically, this node has to be removed, and the resulting list should be returned. The approach we can follow to solve this is two pointers approach. We would have one slow pointer and one fast pointer. So we'll first advance the fast pointer by n, and from there on, we will keep advancing both the slow and the fast pointer till the fast pointer reaches end of the list. At this point, the slow pointer would be pointing to one node before our target. So if we take this example, the slow pointer would be pointing here when the fast pointer has reached the end of the list. And then we can skip the target and return the head. Let me put the pseudocode, which we will convert then into Java. So first would be initialize slow and fast pointers. Then we will advance fast pointer by n, advance slow and fast pointer till fast reaches end of list, skip the nth node, return result, right? So let's convert this into Java now. So we have list node slow is equal to head, list node fast is equal to head, for int I is equal to 0, I less than n, I plus plus, fast is equal to fast dot next. One of the constraint is that n would always be less than size of the list, so we don't need to put any null checks for that. After this, we will be checking while fast not equal to null and fast dot next not equal to null. Advance both fast and slow, fast dot next, and slow is equal to slow dot next. So at this point, slow is pointing to one node before the target that we are supposed to remove. So let's skip the target node if slow not equal to null and slow dot next not equal to null. Then basically slow dot next is equal to slow dot next dot next. So that would skip a target, then return head. So this should do. One corner scenario that we will have to handle is when n is equal to size of the list. So in this case, after this first for loop, the fast is actually pointing to null. In this scenario, basically, our head should be pointed. So it is the first element that we need to remove. So we can achieve that by advancing the head. So if size of list scenario, if fast is equal to null, then basically head is equal to head dot next, right? So let's try running this guy. Awesome.